My name is Codey Whitt. I work here at Pearson. I'm a senior software engineer with the Grid platform team. We work on the next generation platform for learning management systems, building new things like for new blackboards, canvases, those kind of things. If you guys are aware what those are. We originally started out as a .NET team, and then just last year on August transitioned into a Java Cassandra team. So we had a lot of fun there. We were one of the first ones to do it, so we got to suffer through it. And we didn't have any resources here really to help us out. So we got to make lots of mistakes, so you guys don't have to. So yeah, pretty much just get started here. So you want to use Cassandra. Lessons learned implementing Cassandra at Pearson. What I'm trying to go through is the things that we learned. So for when you consider using Cassandra, you know what to consider about your data, and that if Cassandra will or will not work. This is kind of more of a beginner track level thing. So if you guys are advanced with Cassandra, you might be bored. I apologize. So also, if I'm wrong with anything, just call me out. We'll work through it. It'll be good. So first thing with Cassandra, you need to approach your data model a bit differently than how you would from relational world. You don't have joins, you don't have unions, you don't get to have all these fun, fancy SQL queries to build the data how you want to see it. So you have to do things a lot differently in terms of how you think of your data. No, not only your data, but how you plan to retrieve it, because Cassandra bases its retrieval mechanisms off of how you put your data into its tables. So when you're putting stuff into your column families, the way you build your composite keys or whatever is how you wind up looking things up. You also need to make sure that Cassandra can store it in an easily retrievable manner. You don't want to try to store data it's not easy to retrieve. For instance, you've got some sort of broad thing like you want to do a lookup on give me all the users that are male or female or whatever. Doing those kind of lookups are a little bit harder on Cassandra because it just scopes like throughout the entire ring versus a single partition. So Cassandra should do a lot more work. Also, you want to make sure like the data will scale well and not break Cassandra in the long term. And what that has to do is Tombstones and stuff that I'll explain later. Yeah, exactly. Start a drink count over here in a second. So that pretty much gets through the whole data modeling section. So about your data, you want to develop a good data partitioning strategy. What you don't want to have happen with Cassandra is since it manages its own partitions in terms of it knows where your data goes based off of a hash it does on the partition key or the primary key from relational world. You don't want to use a broad thing as that PK because what will happen is it'll wind up storing. For instance, we store in our system we store course structure, and so we store our data in terms of we have a course ID and then like the items that are in that structure. So if we were to just say store it as the course and say give me everything as a course, what it's going to do is Cassandra is going to actually store it on only the nodes that are responsible for that partition course. So in this case, we have 6 nodes in our ring. Replication factor of 3, which means whenever we write data, it goes to 3 nodes. If we only used course as our thing, all of our data would only go to 3 nodes and only 3 nodes. So what you have to do instead is use like something that's more unique, like the course ID. So since we have unique course IDs for our system, we can say, okay, stored by the course ID. So then Cassandra will take that, make a hash of that key, and then it can distribute it evenly across the nodes. So that helps out a lot better with Cassandra. You know how you need to search your data, so you know what lookups you're going to do. For instance, on us, we have to be able to look up against the actual item ID itself of the thing in the course. We have to look up based off of giving all the items in a course. We have to look up giving all the items in an assignment, things like that. So when you store that data in Cassandra, you have to actually make column families for each one of those ways you look up. Otherwise, because unlike relational worlds, you just do a give me this where column equals X. If that column is not indexed or part of your composite key, Cassandra won't do it. It'll just bomb out and say, you can't do that. Not doing it. And the reason why is because it would have to go across your entire node and search all the data, and that's just not scalable when you have a bajillion records. Limit the number of updates and deletes on data that must be indexed. This helps on the low level of Cassandra to manage its tombstones. And that has to do with how Cassandra handles deleting across systems. Because if you just deleted the record immediately, you wouldn't be able to replicate that. Because the next node would say, give me this record. If that record's gone, then how would it know it was never there in the first place? So what Cassandra does, it just does a soft delete, and so other records can come in and say, hey, give me that record, and the record goes, oh, I'm already deleted, you don't need me anymore. It moves on. Also, denormalize all the things. Cassandra does really well in terms of having denormalized data. Data's cheap now, so you don't have to worry about like running out of data, because if you need more data, you add another node. Adding commodity nodes, it's just the cloud way to do it. If that's not good with you for your setup, you might want to reconsider Cassandra, because that's just the kind of design philosophy behind it. And this is all, like I said, so when I look at Cassandra, I kind of feel like it's like my first 6 weeks in my database class back in college. But before you've learned all your normal forms, you just need to throw all those out the window, go back and for the same place. You're gonna write the same data multiple times. We have for our assignments, for instance, we look up by course, by external context, by internal context. We have, I think, 5 different lookup tables. So when we actually write one assignment record, we have to write the 5 tables. So, and Cassandra provides batch statements to make that easier. They're atomic, so you don't have to worry about data synchronization. So things Cassandra does well, non-relational data, really does that best. If you have relationships, you need to denormalize your relationships out, so where you have all the data you need to see in one column family. Cassandra has maps and sets that you can also store as part of its data types, so that helps. So if you need to have like things that have many things, that's one way to approach that problem. You want to have permanent data, immutable data, in terms of the less number of updates you're doing, the less number of deletes, the better. Because Cassandra likes just to store data. It doesn't like to do things with it. It can, and it will do it fine, but it does it a lot better if it doesn't have to. And then you got to store your data as it should be viewed. Like I said, so if you need to see it one way, you don't build a view like you would in SQL. You just store it at the column family level. Things it does not do well is constructible views across data, like I just said. Queue-like data patterns, where you're inserting something in and then popping it off after you use it. Again, that's a high delete scenario. You don't want to do those kind of things. Those can get really hairy. They can actually wind up crashing your servers. They'll cause really weird things, such as too many file open exceptions, and it's just fun as hell to try to debug. Also, highly volatile index data, meaning any data that you need to look up against, you don't want to change. Anytime you have to update that column that's indexed, you're actually deleting a column and then reinserting it. So you want to make sure you avoid doing that, because if you don't, you'll start building up tombstones, and tombstones are the devil. So we'll move on. I'll get to those in the future. You guys will understand what's going on with that. So yeah, searching your data. Do not rely on a single column family to handle all lookups. Like I said earlier, I keep reiterating a lot of this because these are the problems we ran into when we first approached this. We luckily later figured out, oh, hey, some other people probably did this, and we found some talks by Netflix and Spotify. They showed us how to do it. We realized we did everything wrong. So this is our walkthrough of what you should avoid. So yeah, use a single set of data, like I said, can be stored on multiple column families depending on how you need to look it up. It's pretty easy, just multiple things, do batch inserts, batch deletes. That's how you just manage to keep everything in sync. They're all atomic, so if one fails, it'll back it out and stuff. And then avoid secondary indexes in almost all use cases. Secondary indexes are indexes that you use in Cassandra that aren't part of your composite key. And there are very few use cases where they're used well. So just avoid them like the plague, unless you know what you're doing and know how to use them. And unfortunately, I'm not one of those people, so I'm going to ignore that. So this is my approach on this. Use secondary indexes for your lookups. You're going to have a bad time.
On the order of 500 plus milliseconds for a query versus 50.
Yeah. Well, there was one point so you guys had it for a while there in your stuff, and then your queries actually want to time me out at some points, right?
I don't know if we were timing out, but we were definitely in excess of 500, 600 milliseconds for a query that should have taken less than 50.
Yeah, because it's just essentially what happens with secondary indexes is that Cassandra, one node does not know what's on all the other nodes, and since all your data is distributed amongst all the nodes, the way the indexes work is they only know what's on that one node. So what happens is when you send your request to your coordinator, it goes to every single node in your ring, asks them for the data that's on there, and then what it has to do is it takes those entries in that index and it has to do disk seeks to find all that data, because all that data is not contiguous since it's not stored in a way that Cassandra has it in order. So once it's doing all this random I/O, then it has to push it all back to the coordinator. Coordinator merges it all together and then sends it back to the stuff. So when you have this happen on a large scale, Like it just times out. It'll go out there, it'll do its thing, you'll hit 10 seconds, and then the query will just say RPC timeout, and you're done. Like that's all you can do. And it doesn't take much to get to that point. 100,000 rows and you're there. So it really just breaks your scalability stuff. What I've heard is that the best approach is to use it with low cardinality type things. It's the exact opposite from relational databases. You want, like in relational, you want high cardinality indexes. You want low cardinality indexes in Cassandra. The lower like states or country or gender, those kind of things work better. Still, if you're looking at secondary indexes, I would suggest looking at something like Elasticsearch first. Searching your data. Avoid indexing volatile data. Like I said, if you index volatile data, it's hard for Cassandra to store that in an efficient manner. Limit your lookups to a single partition where possible. This all has to do back to that Tombstone thing we're going to get to. And the thing is that when you search across partitions, you're essentially doing a table scan across your entire ring. So if you limit it to a single partition, the coordinator will know what nodes have that data and only send the request to those nodes, and it won't have to go across everything. It also limits the number of records that are wound up being read. It limits the amount of memory Cassandra can use, and you have less chance of doing like out-of-memory exceptions, which will crash your Cassandra service. So Tombstones, that I keep mentioning over here, this is essentially the quickest way to kill your Cassandra service. So all Tombstones are just soft deletes in Cassandra. On the low level, what it's doing is it's when Cassandra writes your rows, either wide or skinny rows, however you've done it, it stores your data with a timestamp and all that fun stuff. So when you look at the data, you'll see the column name, the data value, and the timestamp. When you delete it, all it does is changes the data value to a null, marks a tombstone flag as T or D, depending if it's a tombstone or a column, and then it sets another timestamp saying when it was deleted. So that way you can, when another node asks it for data, you can compare and say, oh, its data was already deleted. So that's how it keeps in sync and consistent. The problem is when you do a request against Cassandra, is it has to read those tombstones to know like what data to return back. So, for instance, when we ran into this problem, it was in perf testing because our perf engineer only used one course to test against on all of our stuff. So we kept inserting stuff against this one partition over and over. So we start out with like 5 items. And so when you do a select on it, you can do 5 back. Once you get to start adding and deleting, say you've added and deleted 50 items, but you still have 5 items in there, you do a select. Cassandra actually looks up 55 records, prunes out the ones it doesn't need, and then returns back what you need. After time, this builds up and builds up, and what can happen is Cassandra can run out of memory and crash. So what they did to prevent this is they set a hard limit at 100,000 tombstones. If you hit that number, your query just stops, and it doesn't tell you why. It'll look, everything will be working up to a certain point, everything will be performant and great. You'll get like, maybe 200, 300 millisecond responses because you have a lot of data to go through. And then all of a sudden it'll just start timing out, taking 10 seconds to time out. And it won't tell you why. And the only way you can find out is when you turn tracing on and run the query yourself. And then you'll see it says 100,000 tombstones encountered, aborting query. And then it just lets it time out and waits until it's done and just kicks it out. So there's only thing you see in the logs is up to that point you'll see a bunch of messages about tombstone warning thresholds, like encountered 10,000 tombstones for 3 live records, stuff like that. So if you're starting to see a lot of those in your logs, you might want to look at your data model, make sure you're not doing too many deletes. So yeah, all that stuff I just went over. So what else? Managing tombstones, you just need to avoid data models that update index columns. Like I said, anytime you update an index column, you're actually doing a delete and an insert. When you don't want to have too many deletes, so it's the same type of thing, and you need to query data, avoid data models that query data across partitions. If you're only hitting one partition, your tombstone number only matters to that one partition. If you're going against all partitions, then you're suddenly checking every tombstone that's in Cassandra that it encounters trying to read your data. So if you limit to one partition, you probably won't have trouble with tombstones. Try to make your data as mutable as possible. If you're not changing your data, if you're just pushing it, setting it, forgetting it, you're not going to have tombstone problems. And then you can also fine-tune your garbage collection settings on the per column family basis. And what that does is you set the GC grace seconds value on it, and it's by default 10 days. So tombstones live on your server for 10 days before they're compacted and cleaned away. You can set that down to like for us, since we do repairs nightly, we can set it down to 1 day. So that way we have a much shorter threshold for tombstones to build up. And what happens is when the garbage collector comes in whenever compactions are done. There's some, I think Spotify said that if you're using wide rows, the tombstones only disappear on major compactions. I talked to the data stacks consultant, and he said that that's the case, that's a bug. So I'm not sure if that's true or not. I haven't had a chance to really go through and debug that. So you might want to keep that in mind as well. That brings us to operationalization of the Cassandra cluster. I've been staying in front of this thing the entire time, haven't I? Okay. Cassandra requires more maintenance than most relational databases. MySQL, you spin it up, leave it there for years, and don't have to touch it. Just make sure you don't run out of space. Cassandra is not that way. Cassandra is very high maintenance. It's very needy. It wants you to go and talk to and hang out with it every now and then. So what we have to do is you have to run repairs at least at the minimum, at least as often as your smallest GC gray second setting is. So if you're using the default, you have to run a repair at least once every 10 days. If you set that to a lower number, you need to run it as often as that. If not, you can run into consistency problems where data will delete and then it'll come back. And you'll be like, where did this come from? Or you'll even have, so when we first started this out, we didn't repair ever. Like, we just let it go for months. And we just started noticing that our data, you talk to one node, it's one thing, you talk to another node, it's completely different. And we couldn't figure out how to reconcile this. Like, our tests were just failing out of, it would be random. We couldn't figure out why some tests would fail and they would start working again without, like, it was bizarre. And then we realized, oh, we're just not maintaining our database properly. Like I said, it's a strange difficulty to debug issues will arise when your cluster is neglected. There's no errors that are in the logs. There's nothing that tells you that something's wrong other than your data just not being consistent. So you just got to make sure you're performing your maintenance jobs regularly and possibly perform major compactions. But mostly when you do these, those are to help your read performance. So if you're a high read, low write system, major compactions can help keep your data in a single table, or SS table for it. So when Cassandra goes to read, it just has to do a sequential disk read versus have to do random IO. So the data stacks consultant told us to try to avoid this unless you need it. So keep that in mind. That's it. So thanks. Any questions?